In this video, we'll be learning to solve equations with two steps. Now, this is an extension of the previous lesson where we solved equations with one step. It's a natural extension. In fact, I would go so far as to say that many of the lessons, or most of the lessons we've done up to this point, have all been building up to this lesson, solving equations with two steps. You're now going to do this and you're going to really get into the heart of what algebra is. And you're really going to learn and understand how to manipulate equations with variables and numbers. Now, the goal of this lesson is right there in the heading, solving equations with two steps. So first, let's define what a one-step equation is and what a two-step equation is. A one-step will look like x plus 3 equals 7. That's a one-step equation. Now, a two-step equation will look like 2x plus 3 equals 7. Okay, when you look at these, what do you notice? Well, you'll notice that on the left side, we have one operation, that's addition. And on the right side, we have two operations taking place, addition and multiplication. So that complicates what we learned in the previous lesson with one-step equations. So with one-step equations, we learned that you perform the inverse operation and you would get x equals 4. And you are complete. And this would be step 1 right here, the -3 on both sides. Take one inverse operation, isolate the variable, and you're done. So with two-step equations, that changes. You have to take multiple steps, 2 steps, but these 2 steps can be extended out and take multiple steps using the same strategies. So one thing to consider is that when we see 2x plus 3 over here, we need to approach this in a particular manner because you have 2 steps. You could do addition or you could do multiplication. Well, you have addition and multiplication, and you could do the inverses of those. You could do multiplication or you could do division. So you're at kind of a crossroads. How do you know which one to approach it with? Well, I'm going to put it to you this way. When you are doing algebra, think about this. You're undoing operations on both sides of the equation, right? Well, when you have a 2-step or multiple step equation, think about reverse PEMDAS. Anything that's in PEMDAS, do it in the reverse way. Think about that at first as a framework. Or secondly, well, not secondly, but another method is to think about isolating the variable. So the correct or the best way and the simplest way to approach this is to subtract 3 from both sides. Subtract 3 from both sides and get 2x equals 4, and then divide. You have a one-step equation now, so you just need to divide and you'll get x equals 2. That is the best way to solve that equation. Now, there's a beautiful thing about algebra, and that beautiful thing is that so long as you do valid operations and valid manipulations, you cannot go wrong. Now, what do I mean by that? I'm going to show you what that means, but I do not want you to get confused. This is not the way you should approach this problem, and it makes it needlessly complicated. You always want to approach it the most simple way, but due to the methods we use in algebra, you can do it this way. But remember, this is not the best way to do it, so I don't want you to get confused. But let's say we've seen this two-step equation and we decided at that fork in the road that we wanted to divide both sides by 2. We want to divide everything in this expression by 2. We would get x plus 3 over 2 equals 7 over 2. We would subtract 3 over 2 from both sides, and we would get x equals 4 over 2, which also equals 2. So we get the same solution. But that was a little more complicated than just approaching it the other way. That was more than a two-step equation. So we wanted to make it 2 steps. All right. I know that was a little long, but I wanted to give you a good, thorough introduction to that. So let's do some examples. Let's put up here 2x plus 5 equals 13. All right, when I see this, let me think about the easiest way. I want to do the inverse operation, and I want to do addition and subtraction before I do multiplication. So let's isolate that variable. Let's subtract 5 from both sides. That will give us 2x equals 8. Now let's take our second step and divide both sides by 2 to get x equals 4. All right, that one's solved. Let's try x divided by 3 minus 4. Okay, I'm expressing the division as a fraction here. You're going to see that a lot. So this is the way you'll often see division, x divided by 3 expressed in algebra. So get used to that. This is equivalent to x divided by 3 if you've never seen this, okay? All right, so we want to do inverse operations. We want to isolate that x. What's the simplest thing we can do? It will be addition, add 4, and we get x divided by 3 equals 10. Okay, now what we need to do is multiply both sides by 3. Multiply by 3. That's our second step. When we multiply something divided by 3, that's the inverse operation, so it'll cancel it out. And we'll get x equals 3 times 10, which equals 30. All right, so just again to re-emphasize, a common mistake is to approach this problem by doing multiplication or division steps first and trying to do it that way. That's going to needlessly complicate and muddy the waters of your solving the problem. Let's scroll down, and we're going to set up a set of practice problems for you to get some work doing two-step equations. Okay, here's the problem set for you to work through on your own, solving two-step equations, and then I'll quickly work through them myself. Great, I'm sure you paused the video and breezed right through these. If not, pay close attention and you'll be able to get this. 3x plus 4 equals 19. Let's subtract 4 from both sides. We want to do our addition and subtraction first. We get 3x equals 15. We divide both sides by 3, and we get x equals 5. That is our final answer. X equals 5. We pop right down to x divided by 5 plus 7 equals 11. We want to subtract 7 from both sides. Remember, do your addition and subtraction first. We get x divided by 5 equals 4. Now what we're going to do is multiply both sides by 5. Multiply both sides by 5. And the 5's over here cancel. And we get x equals 20. That is our final answer for that one. Moving up to pink over here, we subtract 6 from both sides. We subtract 6 from both sides. And we get negative 2y equals 4. I don't love this one. I hope this one didn't confuse you, but it's a little bit of a challenge problem for you in that case. We need to divide both sides by negative 2. Divide both sides by negative 2. Don't feel bad at all if that one, you weren't sure how to solve that one. When we divide a positive by a negative, we get a negative number, so we get y equals negative 2. That is our final answer. And now we have 4x minus 9. We'll do addition first. Add 9 to both sides. And we get 4x equals 16. We divide both sides by 4. And we get x equals 4. This is our final answer. X equals 4. So that's the practice set for today and this lesson. In the next lesson, we will learn to solve equations with variables on both sides. Thank you very much for joining me here, and have a good day.